Today in this video we're going to discuss about introduction to functional dependencies. In this topic we will learn about first normal and second normal and third normal forms. Come guys, let us start the session. Introduction to functional dependencies. Functional dependencies are actual concepts in a database management system. They define a relation between attributes in a relation or a table. Definition and explanation of functional dependencies. Understanding dependencies and formal dependencies. What is meant by understanding dependencies is nothing but functional dependencies ensure the specific combination of values in attributes. There exists only one value in the set. Then what about normal definition? In a given relation, you can see the relation here, over here. In a given relation, attribute y is a functionally dependent on attribute x if x and y value is associated with them itself. Then we will call it as formal definition. Next one, example of functional dependencies in a database management system. In this database management system, there are three functionals like row data. We can also call it as tuple. Whichever data is covered in a row, that we will call as a tuple, and whichever data or whatever the data all are covered in a column, it is called attribute. In this row data, our database table containing student information with column for ID, name and address. And the functional dependencies are addressing functionally dependent on ID, where student ID is uniquely determined their address. For example, consider student details are like he can have his name, his address, ID, Gmail and other thing like phone numbers. In this there are three unique candidate keys we can found it out. They are student ID and phone number and email address. These are candidate keys. We can't say that there are three unique contents, unique details, so that we can't say that those three are unique or primary, because we should know that we need to identify a student by his own ID. Otherwise, if we got a number or if we choose a email ID, there are a lot of students, like thousands of students. We can't check the each student each student number or email ID. In a student ID, it is assigned in a ascending order, so that we can easily identify the identify the student who will be the next one or who will be the previous one. We can easily identify it, right? So that student ID is primary key. Also in this example, if we take an university, now let us take our university itself, like VTU University. There are lakhs of students out there. If anyone needs to point out any student, like in our college, for one student he need to identify, so that he can't give his whole data or whole information. He doesn't have that much data to provide. So what he will do, he will send a USN. USN is nothing but a unique registration number or student ID, we can say. By that USN, we can easily find out where he is from and which branch he is belonging to and which college he is belonging to. All of the thing or all of the data will be covered in his USN itself, so that that is a unique, and we can easily identify the data. That's what they are trying to say. And application, the understanding of dependencies is utilized in database normalization to optimize data storage. Introduction to normal forms. based on a primary key. Here you can see that countries are Portugal, Greece, France, Croatia, and others. They are like a primary. Uh, no countries are repeated, or no country names are repeated, right? If we are Indians, any other country has a name India? Not all, right? Has the same. Key concepts. Normal form are the set of guidelines to enhance the language structure of a database table. In what about primary key? Normal forms are based on the concepts of primary key, which uniquely identify each records in a table. Is it right? It will, as I told, it will identify the each unique identity in a record or a relation. The next one, first normal form. Here we have atomic values and no repeating groups. Atomic values is nothing but each field in a table should hold a single or individual value. Then what about no repeating groups? Within a heading we can easily understand there will be no repetitions. Eliminating the repeating groups of attribute enhancing data integrity and efficiency. Examples of first normal form. 1NF is a database management system. Data structures. Consider a table with a student information structured according to 1NF, where each attribute contains a atomic value. Eliminates its structure where we can convert the normal information into 1NF. And what about elimination of repetition data? Normalization to 1NF ensures that each student's details are stored without redundancy. It's nothing but in a table or in a relation, the each student has a unique ID, and whenever we retrieve the data, there will be a no repetition of a same student. That's what they are trying to say. Explanation of second normal form 2NF. Removal of partition dependencies and data integrity. In a removal of a partition dependency, 2NF eliminates dependencies on only a part of a composite primary key. Wherever in a data integrity, this ensures that the table is free from update anomalies and unwanted insertions, deletions, and modifications, etc. In removal of partial dependencies, each non-prime attribute is fully functionally dependent on the entire primary key. We can understand that it is dependent on only a primary key, entire primary key. Example of second normal form 2NF. In a database management system, we can see that data redesign and optimized structures. In a data redesign, consider a student course table reshaped to 2NF, ensuring the records are normal of partial dependencies. In optimized structure, we can say that redesign to 2NFA enables efficiency querying or querying and insertion without redundancy. Without redundancy, the efficient is more in a 2NFA. I'm sorry, 2NF. Explanation of third normal forms. In third normal forms or 3NF, we'll know about transitive dependencies and data redefinement. In third normal form, eliminates the transitive dependencies where non-prime attributes depends on other non-prime attributes. Nothing but in a relation there will be a one primary attribute or a primary key, right? Except that other non-prime attributes are dependent on other table or other foreign key. I'm sorry, other keys. It is dependent. Like if we are taking the address of a student, it is there in a normal student information data. From there we need to fetch the student address. Like that, each attributes, non-prime attributes, are dependent on other non-prime attributes. In a data redefinement, it ensures each field containing only data that is functionally dependent on the primary key. In wherever the data refinements occurs, the data is functionally dependent on primary key, a unique key. Example of third normal form are 3NFA in a DBMS. Redefined structure. Consider a database table optimized to 3NF, ensuring the elimination of transitive dependencies. In a data integrity, normalization to 3NF results in a robust and efficient data model, minimizing to redundancy and anomalies. Nothing but it is more efficient, and we can able to access faster in a third normal form. Okay guys, this is all about our video. Thank you guys, thank you for watching our video. If you like the video, please like and subscribe the channel. Thank you guys, see you.